So determine the forces in bars A, B, C, D, and E, F of the plane truss loaded and supported as shown below. If A, B, C, D, E, F is one half of a regular octagon, solve in two ways. So the problem is very, very challenging, and we have to solve this in two ways. The more it becomes more challenging. So the first solution is the shortest one, and unless otherwise you experience this, then it's quick and easy, but you need to experience first. Take note that this is half of a regular octagon. For remember that the sides of regular octagon are equal, but because this is half, so for simplicity, let's just assume that this is 1 meter or zero point 0.5 of x. If you denote this as x, 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 so this is 0.5 of x. But x can be cancelled, so just make it this 1, 2 meters the other sides, then this is 1 meter, so that we can easily compute for the angles. We can also express this as 0.5 x, 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 x. We can still solve for the angles because x can be cancelled. So this angle is 45 degrees. Remember, for a regular octagon, this is also 45 degrees. Then for the other members, this and this equal this member, and this member makes an angle of the same. So these two are equal. So this distance is 2 meters cosine of 45, so that's square root of 2 meters. Same is true here. And because this is 45 degrees, the vertical distance between D and E is also square root of 2. Same is true with B and C. So that this distance is equal to 2 plus square root of 2 plus square root of 2, 2 plus 2 square root of 2 meters. So we can now solve theta AE, which is equal to theta BF also. Tangent of theta AE is 1 over quantity 2 over 2 square root of 2. So theta AE, which is equal to theta BF, is 11.701 degrees. Again, this is arctan of 1 meter over 2 plus 2 square root of 2. You get that. Then tangent of theta AD is equal to theta CF. It is equal to arctan of 1 plus square root of 2 divided by 2 plus square root of 2. Again, arctan of 1 plus square root of 2, this angle here, which is equal to this angle. Arctan of quantity 1 plus square root of 2 divided by horizontal distance 2 plus square root of 2. You'll get 35.264 degrees. So for the reaction, summation forces horizontal, so A horizontal is Q also. Then the vertical, we do not know yet. Call that A vertical and RF. So let's solve for A vertical by setting moment F0, summation moment F0, clockwise positive. So we have AV times quantity 2 plus 2 square root of 2, then plus Q times 1, then minus Q times square root of 2. So AV can now be solved. AV is 0.08579 Q upward. Then RF is simply summation forces vertical. So it is equal to Q minus 0.08579 Q. I will not, you just subtract 0.08579 from 1, or Q minus 0.08579 Q. So RF equals 0.91421 Q. Then we consider this sectioning as shown in the figure. And we involve forces inside this section. So AV is involved, Q is involved, and FAB is involved, FCD is involved, FEF is also involved, all these unknowns here. And there are members that are cut twice, So it doesn't matter because they are cut twice. So this is FAB involved, FCD involved, and FEF involved, the red ones. Then I'll show you that these members that are cut twice, green arrows are opposite. So don't mind because they are cut twice. So we consider again forces, especially the red ones, and this AV and Q involved in the moment equation. So that we can solve FAB right away. There is intersection between CD and EF, which is here. I'll call that point G1. Same is true with CD and AB. They meet here. I call that G sub 2. So first, summation moment at G1 equals 0, clockwise positive. So we have FAB times 2 plus 2 square root of 2, the moment arm. Then that's clockwise. So plus Q times quantity 1 plus square root of 2 plus AV also. AV is 0.08579 Q. The moment arm is 2 plus 2 square root of 2. Then plus Q times quantity 1 plus square root of 2. So those are the involved forces. Then we cannot solve FAB in terms of Q. Minus Q times square root of 2. I forgot to include this. So solving for FAB is negative 0.2929 of Q, and that's the answer. FAB is 0.2929 Q compression. Then for FCD, just summation forces, R horizontal equals 0. So going to the left positive, so we have FCD, then plus Q equals 0. Those are the only horizontal forces inside this cutting section. And we can solve FCD. It is equal to negative Q, or FCD is Q compression. Anyway, there's a second solution, but it's very lengthy. Actually, there is a third solution, but only for civil engineering students can experience that. We call that method of substitute members. I have uploaded a similar problem which I solved in 3 ways, but the first 2 ways are here, similar to this. Then for FEF, you may sum up forces vertical or moment G2 equals 0. Then let's check later if it is in equilibrium, summing up forces vertical. So clockwise positive, we have FEF times quantity 2 plus 2 square root of 2, moment arm, plus Q times 2 plus square root of 2, then 0 passes through, then plus Q, this Q here, AV is not involved, plus Q times 1 plus square root of 2, and that's it. Then we can solve FEF, which is also negative 1.207 Q. So therefore FEF is 1.207 Q compression. So that's it for the first solution, as short as that. The second way will be on the next slide. So this is the second solution, and it is lengthy, but you will arrive at the same results. Determine the forces in bars A, B, C, D, and EF of the plane truss loaded and supported as shown. So already computed. So just review the calculations. 45 degrees, 45 degrees. Then remember the distances. Then the angles. Theta AE equals theta BF 11.701. theta CF equals theta AD 35.264 degrees. How to solve for 11.701? Arctan arc for theta AE, arctan of 1 over quantity 2 plus 2 square root of 2. How to solve for theta AD? I already mentioned this. Arctan of 1 plus square root of 2 over 2 plus square root of 2. So 35.264. So first we proceed to join C. Moment F0 to solve for AV. Just like before, AV times 2 plus 2 square root of 2. Then plus Q times 1. And minus Q times square root of 2. So that's why AV is equal to 0.08579 of Q upward. RF is just Q minus 0.08579 Q. So RF is equal to 0.91421 Q. Same as before. So we start with joint C. These are the forces involved. This is required. That's why it's red. Then FCF. So let's express all these forces in terms of FBC. Then after C, we proceed to D, D to E, then F. Then at F, we can solve for FBC in terms of Q definitely. Then when BC is in terms of Q along the way, then EF is also required. It will be in terms of Q. So RCV is 0, downward positive. So we have FCF sine of 35.264. This angle here, 35.264, the vertical component, downward positive, plus FBC sine of 45. So we can express FCF in terms of FBC. FCF is negative 1.2248 of FBC. Then RC horizontal equals 0. So FCD equals FCD plus FCF cosine of 35.264 minus FBC cosine of 45. So substitute the value of FCF. So F0 equals FCD plus negative 1.2248 FBC cosine of 35.264 degrees minus FBC cosine of 45. So FCD can be expressed in terms of FBC. It is positive 1.7072 of FBC. Then after joint C, we proceed to joint D. These are the forces involved. So first, RD horizontal, RD vertical equals 0, downward positive. So F equals FDE sine of 45, downward positive, remember, plus FAD sine of 35.264, this angle, then plus Q. So express FAD in terms of FDE. So negative sine 45 over sine 35.264 is negative 1.7321, negative 1.2248 FDE. Then Q to the left, negative Q divided by quantity sine 45 plus sine 35.264 is negative 1.7321 of Q. Or negative Q over sine of 35.264, sorry. So negative 1.7321 of Q. Next, RD horizontal equals 0. So equals FDE cosine 45 minus FAD cosine FCD, then minus FAD cosine 35.264 degrees. So substitute the value of FCD, which is in terms of FBC, and FAD, which is equal to this. So 0 equals FDE cosine 45 minus 1.7072 FBC minus FAD, which is negative 1.7321Q minus 1.2248 FDE, then cosine of 35.264. So combined FDE, cosine 45, then negative negative, so plus 1.2248 FDE cosine 35.264 is 1.7072 FDE, then minus 1.7072 FBC, then 4Q negative of negative 1.7321, so positive 1.721Q, cosine of 35.264 is 1.4143Q. So finally, FDE in terms of FBC and Q is FDE equals FBC minus 0.8284Q. Transpose this to the left, then divide by 1.7072, so that's why FBC. Then negative 1.4140Q divided by 1.7072 is negative 0.8284 of Q. Then we proceed to joint E. These are the forces involved. So RE horizontal equals 0 first, or summation forces horizontal 0, leftward positive. So equals FAE cosine of 11.701 degrees, the angle it makes with horizontal, plus FDE cosine of 45. So replace FDE with this value here. So 0 equals FAE cosine 11.701 degrees plus quantity FBC minus 0.8284Q, quantity cosine of 45 degrees. So we can now express FAE in terms of FBC and Q. FAE is, use your calculator there, 0.7221 FBC plus 0.5982 of Q from this equation here. Then RE vertical equals 0. So equals FDE sine of 45. Vertical component of FDE is FDE sine 45 minus FAE sine of 11.701, then minus FEF. Substitute the value of FDE, which is quantity 0 equals quantity FBC minus 0.8284Q sine of 45 minus FAE, which is quantity negative 0.7221 FBC plus 0.5982Q times sine 11.701 degrees minus FEF. Transpose FEF to the left, then we can express FEF in terms of FBC and in terms of Q. So 0 equals 0.85355 FBC, combine FBCs here, sine 45 and positive 0.7221 FBC sine 11.701 degrees is equal to 0.85355 FBC. Then for the Q, you just combine, that's the value, then FEF. FEF therefore is 0.85355 FBC minus 0.70708 of Q. Then we proceed to joint F. Forces involved are FEF, FCF, which is known already, then FBF, which is still an unknown. So RF horizontal equals 0, considering leftward positive. So we have FBF cosine of 11.701 degrees plus FCF cosine of 35.264, horizontal component of FCF. Then from there, we can express FBF in terms of FCF. And FCF is negative 1.2248 FBC. So 0 equals FBC cosine 11.701 degrees plus quantity negative 1.2248 FBC cosine of 35.264. degrees. So FBF can now be expressed in terms of FBC. It is equal to 1.0213 of FBC. Then RF vertical equals 0. So equals FEF plus RF plus FCF sine of 35.264 plus FBF sine of 11.0701 degrees. So replace RF, FCF, FEF in terms of FBC. So 0 equals 0.85355 FBC minus 0.70708 Q. That's FEF plus RF, which is 0.91421 Q. Then plus FCF, plus quantity negative 1.2248 FBC, then sine 35.264. Then plus FBF, which is plus 1.0213 FBC, sine of 11.701 degrees. So using your calculator, let's combine all the FBCs and all the Qs. 0 equals 0.35354 FBC. After we combine, then for Qs, 0.20713 Q. Use your calculator there. Finally, FBC is, in terms of Q, negative 0.58587 Q. Negative 0.20713 Q divided by 0.35354. That's the answer. That's FBC in terms of Q. So having found FBC, we can now solve for FEF, which is required. FEF is equal to this. FEF is 0.85355 of FBC, and FBC is negative 0.58587 Q. Then minus 0.70708 Q. So FEF is equal to negative, and it is compression, which is the same answer as before, first solution. Then we need FCD. FCD is 1.7072 of FBC, and FBC is negative 0.5857 Q. So FCD is 1.7072 of negative 0.5857 Q. So we can now solve FCD. It was negative Q, or Q compression. This also will give us Q, negative Q. So FCD is Q, which is the same as before, compression. Then finally, FAB. So it's still far. So we need this force FBF, so that when we transfer there, we can sum up forces vertical, we can solve for FAB. So FBF is 1.0213 of FBC. Let's put that here. FBF is 1.0213 of FBC, and FBC is negative 0.5857 Q. So FBF is negative 0.59835 of Q. Then we draw the FBD of isolate B. These are the forces involved. Then red for FAB. So at B, RB vertical equals 0, because anyway these are in terms of Q already. So 0 equals FBC sine of 45, the vertical component of FBC, then minus FBF sine of 11.701 degrees, then minus FAB. Substitute FBC. So 0 equals quantity negative 0.5857 Q sine 45 minus FBF, which is quantity negative 0.59835 Q sine of 11.701 minus FAB. So it is FAB here, FAB to the left. So FAB is negative 0.5857 Q sine 45 plus 0.59835 Q sine of 11.701. So FAB is also negative. If you compute negative 58587 sine of 45 Q, then plus 0.59835 Q sine of 11.701, it's negative. So that's why FAB is 0.2929 Q compression, which is the same as the first solution. So that's it. It's very lengthy because the problems are challenging, and there are two problems here where we present which I present two solutions.